Okay, this lecture is about the general concept of artificial intelligence and some of the ways that we might usefully categorize the many different kinds of things that have been said to fall under this general umbrella. So the first question is, what do we even mean by artificial intelligence? There's a lot of things that people sometimes mean by using this phrase, and some people want to use the term in a very specific way, such that even the very impressive systems of the past few years don't count. Maybe they're just artificial stupidity, but I think it's much more useful to consider the term very broadly. So let's start by thinking about what is intelligence. We probably first encounter this concept when we think about the difference between a good idea and a bad idea. If you can't find your keys, it's probably a good idea to check the pockets of the pants that you were wearing yesterday. And it's probably a bad idea to just ignore the keys and go out all night with your friends, hoping your roommate doesn't lock you out before you get home. Note that a good idea or an intelligent idea isn't necessarily one that actually works. The keys might not be in your pants pocket, but it's one that makes effective use of the information that you have. Similarly, a bad idea isn't necessarily one that goes wrong. Maybe your roommate doesn't lock you out. Maybe you discover that you had your keys all along in the bottom of your bag, but it's one that doesn't make effective use of the information that you have. We sometimes talk about as though some people are more intelligent and other people are less intelligent, thinking that some people systematically make more intelligent decisions and have more intelligent ideas, and other people less so. But as soon as we try to make this precise, we discover that it's much more complex than we thought. There have been various attempts to develop a measure of intelligence, often called IQ, but even if you haven't studied the history of this concept very closely, you're probably aware of some problems with it. It just isn't always the case that people who tend to have good ideas about how to solve math problems are the same people who tend to have good ideas about how to manage people's emotions, or are the same people who tend to have good ideas about how to cook interesting and delicious food, or are the same people who have good ideas about how to write a song. Some people might quibble about whether or not some of these things really count as intelligence, but I want to use a definition that counts them all as kinds of intelligence. The basic idea I'm going to use is that intelligence involves three things: the ability to take in and process information, the ability to learn from this information, and the ability to use this information to make progress towards some sort of goals. All of the different kinds of intelligence that I've gestured at so far are some version of this. It might be that some people have versions of these abilities across the board and that they truly deserve to be described as more intelligent than others overall. But to me, it seems much more likely that everyone has more or less of many different capacities, many of which can be described as some sort of intelligence. Now, one thing that I think is useful about the definition that I've given is that it doesn't presuppose anything about what kind of being that we're talking about. This definition could be applied to animals, or to aliens, or to angels, just as well as to humans. By the definition I've given, a frog has some kinds of intelligence. It has the ability to take in information through its eyes and ears and other systems and process that information in order to achieve goals like feeding itself and avoiding predators. We might want to say that a human is more generally intelligent than a frog because a human can take in more kinds of information and can learn more effectively from these kinds of information and can perhaps apply this information to more kinds of goals. But the frog definitely has some kind of intelligence, and there's probably some kinds of intelligence that a frog has more of than a human. Now, there are other things like a rock or a planet that we don't think of as intelligent at all, and we can see that this definition gets that right. Rocks and planets don't have goals, and they don't process information or learn from it. Even more complicated inanimate objects don't get counted by this definition as intelligent. It's hard to see what sort of goal a river or a fire or a tornado might have. Maybe you could say a little bit, but none of them seem to have information that they take in ways that help them achieve those goals. But this definition does say that things like plants and bacteria have some sort of intelligence. They do process information and use it to achieve some sort of goals. You might think that for that reason, my concept is too generous. It counts too many things as intelligent. But I do think that it's going to be useful if we want to get to the most general concept of intelligence and understand all the differences in it in order to understand artificial intelligence. Now that we have the concept of intelligence, we can think for a moment about the concept of artificial. Initially, we think artificial just means made by humans. In his famous paper, Computing Machinery and Intelligence, where he tries to argue that artificial intelligence is possible, Alan Turing notes that although we seem to have some sort of clear idea of what it is to be artificial, it's a bit hard to define. If we just mean made by humans, well, then every human so far is actually an artificial intelligence. We weren't just found under a tree, we were made by our parents. Now, he doesn't mean to count that, and neither do we. He eventually says that he wants to focus on electronic digital computing devices. In 1950, when he wrote that paper, he had to spend some time arguing for why this was a reasonable definition to focus on. Nowadays, we're used to thinking that we must mean our electronic digital computing devices, but it's worth spending a few moments thinking about what other possibilities there might be. So alarm clocks and thermostats and smoke detectors might be purely mechanical objects that count as a rudimentary sort of artificial intelligence. They take in some sort of information and process it in a certain way that achieves some sort of goal. Now, they only each deal with a single kind of information and only use it for a single basic goal, but we could imagine building a more sophisticated device that combines them in more sophisticated ways and thus has a little bit more intelligence, though it's still likely less than your average plant, let alone an animal or a human. Before the 20th century, there were various stories people told, imagining someone creating an intelligent creature out of clockwork, or by assembling parts of dead bodies using biological structures and electricity, or with the clay and the breath of life that they imagined God using to create humans, or with complicated hydraulics and steam, or some kind of magic. While digital electronic computing devices are the forms of artificial intelligence that are most well developed right now, it is helpful to occasionally broaden our imagination, both to understand how we got to this point and also to be open-minded about what new developments might come a year or a decade or a century from now. Right now, all artificial intelligences use electricity and silicon to work, but there could be some breakthrough that means that they use carbon and light, or hydrogen and magnetism, or who knows what. And so given this, I'm going to say artificial intelligence refers to anything that is artificial, not a natural human, probably a digital electronic computing device, that can take in and process information, learn from it, and use it to make progress towards some sort of goal. Something is more of an intelligence if it can take in and process more kinds of information, learn from it more effectively, and use it to achieve more goals more effectively. Okay, now that we have defined artificial intelligence, we can start to categorize the different types. And the categorizations that I think are the most useful are the categorizations either based on what it does or based on how it does it. Okay, so first, let's think about the categorization based on what it does. Many of the most influential ideas of what artificial intelligence is, or could have been, think of it on the analogy of human intelligence, which is quite general and can be applied to many different sorts of information and many different sorts of goals. Such a system is clearly possible, after all, humans exist, but no artificial system has yet come anywhere close to this. This idea has often gone under the name of strong AI, or in recent years under the name of artificial general intelligence, or AGI. As we'll see towards the end of the class, experts in this field have a range of views of when this might be achieved, if ever. A common view is that it might be possible to have AGI by the middle of the 21st century, though there's a few people who think that because of the breakthroughs of large language models like ChatGPT, maybe it'll come just in the next few years. There's also a good number of researchers who think this is going to be so difficult that it probably won't even occur in this century at all because of limitations of energy, computing power, data, and so on. We'll discuss these views later. At any rate, everyone agrees that AGI is still just a hypothetical concept, and all the existing artificial intelligences are special purpose intelligences, or artificial special intelligences. And here, these come in a range of different types. A useful categorization might be between those that identify or classify things, those that recommend things, those that do things, and those that generate things. Obviously, this isn't a sharp distinction. Systems that do one of these often do some of the others along the way, and there isn't even really a clear difference between some of these concepts. But it's still a useful way to start thinking about different examples. And by giving all these examples, I want to help show you there's a lot of different things that already exist that really count as artificial intelligence, even though you might not be thinking of them. So let's first think about systems that identify or classify things. There's a range of different levels of sophistication that these can have, and all of them, I'm going to say, will count as intelligent because they use information about a new object to achieve the goal of identifying which of some pre-existing types it fits into. So for decades, the post office has had scanners that can take an image of a handwritten zip code and identify what digits are written on it. In recent years, there have been various forms of facial recognition systems of varying degrees of sophistication. At the border control, they have a system that has a database of all the hundreds of millions of different passport photos, and it tries to identify which of these photos matches the person who's entering. Your phone has a very different sort of facial recognition system on it. It may have a scan of your face and try to identify whether the person looking at it and unlocking it is you or is not you. Law enforcement often tries to do this with no database at all. They have cameras posted in various places and try to identify if the same person showed up at one site and then later at another site, maybe to identify if there's a suspect, and then maybe later look them up in a database. Social media companies often have systems that are trying to identify photographs that contain violence or nudity to automatically prevent them from being posted. And radiologists are developing systems that try to identify X-rays that contain cancer or other medical conditions and distinguish them from X-rays that don't. YouTube and other video sites have systems to identify whether a video contains copyrighted music, and if so, which song. Now, another interesting classification example that we don't usually talk about as artificial intelligence since it doesn't run on a computer is something like the Arbor Day Foundation's What Tree Is That guide. This book contains an algorithm for identifying what tree you're looking at. On the first page, it asks you, what shape is the leaf? And then it asks you things like, how many veins does it have? What does the bark look like? And by following this flowchart, you can eventually classify which tree it is. Now, many of the older computer systems work a lot like this, where they have a set of rules and instructions they follow, while newer systems work very differently. Other sorts of classification systems are used by employers to classify resumes into the bucket that they'll interview and the bucket they won't interview, or by the justice system to classify prisoners into the ones that they will parole and the ones that they won't parole. So there's lots and lots of different types of artificial intelligence that already exist that try to identify and classify things. Now, there's another type of artificial intelligences that try to recommend things. And there's also a wide range of these. These ones tend to use information about a person's past behavior and information about the objects that they've interacted with to achieve the goal of trying to give the person objects that they're more likely to choose to interact with in the future. Some of these are very obvious. Things like the Netflix or YouTube or Spotify or TikTok algorithm, they all have some sort of system that takes the things that you've chosen to watch or listen to before and uses that to try to decide which ones to suggest for you next. This is like classifying things into ones that you will watch and ones that you won't watch, but it's harder because they're not just trying to think, this is something you might watch, this is something you might not watch. They're trying to figure out which one among all of the many videos is the one that you are most likely to want to watch next. Some less obvious recommendation systems are things like Facebook and Twitter, which have systems for deciding which social media posts to show you and in what order. Google has a system that decides not just what pages to show you for your search, but also which ad to show you. And the ad recommendation algorithm wants to know which ad you're likely to click on. Now, systems that do things are perhaps the most varied category because do is a very general verb. But these ones are the ones that are most clearly something like some sort of intelligence. We've got things like self-driving cars and Roombas and other sorts of robots that move around in the world with the goal of either getting a person to their destination or cleaning the room or whatever else it is they're trying to do. There's also much older devices that I'm going to classify as very rudimentary artificial intelligence. Things like autofocus for cameras, which has existed in mechanical forms since very early in the 20th century, and things like thermostats for climate control, which actually have existed for a long time, maybe even the 19th century, just using different pieces of metal reacting to temperature to control a furnace. There's also much more sophisticated modern versions of both of those. Similarly, if you've ever played any computer game against the computer, then whatever is built into that computer game counts as a sort of artificial intelligence that is trying to do something in the game, not in the physical world. There's, of course, many much more sophisticated AIs that have been trained to play chess or to play Go, which you might think of as recommendation engines for recommending the next move, or maybe they're really things that are doing something. There are some other AIs that clearly are doing something. Like there's one AI that was trained to teach itself how to play every single classic Atari game. The final classification that I'm giving here is one that is a term that's only been used very recently that we call generative AI. And this only became very common after around 2020. These systems all use information from some sort of prompt to produce something that somehow fits that prompt. And this includes large language models, things like ChatGPT or Gemini or Claude, which generate text. There's also a whole set of things that are used to generate images, like DALL-E, which is the system that I use to generate all the images in this slideshow. Uh, there's also Midjourney and Stable Diffusion and many others. These are called diffusion models. And there's lots and lots of new categories of generative AI that are being introduced every day. Things that just generate music or generate video or generate DNA sequences, or mathematicians are developing AIs that can generate mathematical proofs. Now, some people might say that because language can be used to recommend actions or to identify things or to interact with large parts of the social world or more, and because a large variety of goals can be encoded into linguistic prompts, that maybe large language models, these generative AIs, are actually close to a very general purpose intelligence. But I and many others note that there's still a lot of limitations on the kinds of information that LLMs can take in, large language models can take in. And they can get a little bit of image, but not very much. And they don't yet have goals of their own other than producing text that fits the prompt. So we think that there's still a lot more steps that are needed before something like this would count as artificially generally intelligent. I mean, there were earlier examples of this. In the early 2000s, the founders of Google had argued that the search engine was actually close to general intelligence because they said the internet already contains so much information that all you really need for general intelligence is an effective way of finding the information relevant to a goal. But that hasn't yet panned out either. I think it's worth noting that identification, search, recommendation, and language are all very important aspects of intelligence, but also none of the systems that we have yet built on any of them are really capable of replicating anything like the breadth of human intelligence. Okay, I think the other kind of classification that I think is also useful is classifying kinds of artificial intelligence based on how they work. Although it's easier to think about the differences between what they do, it's sometimes useful to think about how they do it. And we'll talk about this much more later on in other videos, but I'll give a brief introduction now. Now, one way of thinking about intelligence has been split for thousands of years between a more Platonic vision on which intelligence takes place in a realm of pure ideas and a more Aristotelian one on which intelligence is something that the body does in interaction with the world. And this distinction has manifested itself in several ways within the field of artificial intelligence. One distinction here is between embodied systems like robots that are equipped with sensors and motors whose operation is based on a position in the world that they occupy, which is different from most of the other systems that we've mentioned, which could effectively operate in the cloud. In Star Trek, we can think of the distinction between the ship computer, which just talks to the characters from anywhere and it can get information from the cloud, versus Data, who is this embodied robot that interacts with the world through his body. Some people might think this is an unimportant distinction, but actually a lot of cognitive scientists and philosophers have argued important keys to human-like general intelligence lie in having a body that interacts with its place in the world. Now, one other, even more important distinction is between the kinds of AI that work like other computer programs with a series of instructions that are intelligently designed by a person, and the kinds of AI that work more like a brain with a distributed system of neurons that learn from experience. And to think about this in human terms, you can think about it like how you might use the Arbor Day Foundation flow chart to identify a tree. It gives you a bunch of rules. Look at the leaf, then look at the bark, then look at these other things. And you can justify exactly how it is that you got to the answer versus think about how it is that you recognize your friend when you see them. That just happens subconsciously. Are you recognizing them based on what color their eyes are, what shape their jaw is, how their cheekbones are aligned? You don't really know, probably, how it is that you recognize each friend. You just do it. And this is how these neural networks work. And these are much less explainable or understandable. But we will discuss this distinction at much greater length over the next few modules. For now, I'll just describe it as the distinction between symbolic systems that work according to rules and neural nets that work on this more instinctual way. Up until about 15 years ago or so, almost all artificial intelligences were symbolic. But the vast majority of the systems that have attracted attention since around 2015 have been neural nets. Most of these neural nets engage in what we call machine learning, where they learn from some training data. And one important distinction that we'll talk about later between machine learning systems is based on what kind of training data they use. There are some systems that learn from just raw data with no extra information, and other kinds of systems that need the data to be labeled. And this is what the distinction is that we might call between unsupervised learning and supervised learning. I won't give you yet a full explanation of the difference, but think about the difference between going out into the forest by yourself and trying to figure out how many different types of trees there are. So you have to figure out which trees even count as the same type and which are different types, versus going out into the forest with a local or with the Arbor Day Foundation book who can point out the different types of trees and tell you their names. Unsupervised learning, like learning for yourself, often requires a lot more data, while supervised learning, which can happen with fewer instances, requires someone intelligent to have already put the labels on the data for you. So those are the different classifications that I think are useful for different kinds of artificial intelligence.